Welcome to Pomodoro Joe for Saturday, March 18th, 2023. Today we're doing LeetCode problem 1472, Design Browser History. It's a medium problem. You have a browser of one tab where you start on the home page and you can visit another URL, get back in history any number of steps, or move forward in history a number of steps. Implement the browser history class. All right, so it looks like we basically have, this is a web browser history module. And so we have an init with a home page. We have visit, meaning you're going to that URL. You can go back and you can go forward. Seems pretty straightforward. All right, we'll put 25 minutes on the Pomodoro timer and get started. All right, so with the init, we just need some storage. So actually, before we jump into coding, let's do a quick look here. So we have an init, a visit, a back, and a forward. Okay, so the init, we need to initialize some storage where we'll store all of our URLs. In the visit, it's kind of like a stack. So in the visit, you just put the URL on the stack. When you go back, you can pop the URL off the stack. But if you pop it off the stack, then you can't go forward. So we'll need to keep not just a stack, we'll need to keep something like a stack. I guess it'll be a list or an array, where we'll just keep track of where we are in that list. And as we go back, we'll just move that pointer back in our list. If we go forward, we can move it forward. But then when we visit, we will have to essentially wipe out everything going forward. Basically, when you visit, you have no more forward to go. So you can either like delete them or remove those elements from our array, or we can keep a separate pointer to say where is the top of our stack. All right, now we can get coding. So the first thing we'll need is our storage. I'll just call it data, and that will be an empty list. Then we need to know where are we in our list. So I'll call it the current index. And it will start as 0. And then we'll need to know what is our maximum index. This is so we can keep track of how forward we can go. And I'll also set that to 0. Okay. Oh, but what do we do about this home page? We will put that in our list to start with. So we start on the home page. All right, that takes care of the init. Let's take a look at our visit. So when we visit a new URL, we'll put that in our storage, but we'll also have to increment our index and reset our max index. So let's increment the index first. So that way, if we already have space in our storage, we can just put our URL at that space. If we don't have space, then we'll have to append the URL to our storage. So let's see. We've incremented our index. This will be the new location for our URL. Now let's see if that is greater than or equal to, let's see. Yeah, we need to know how much storage we have in our self.data here. So we'll have to check length of our self.data. So this tells us how much storage we've got. And our current index, if it's greater than the amount of storage we have, or equal to. So because this one is 0 indexed and this one is absolute, like 1 indexed. So how do we find out like if this is like greater than, less than, equal to, what's our comparator here? So what I like to do is just think about what if we have one element, just like this. We have one element. So our length here will be 1. Our current index, which starts at 0, now we've added to it, our current index will be 1. So we have one element in our array, homepage. We need to add a second one. So we need 2 spaces in our data. But our current length is only 1 space long. And our current index will be index at element index 1. That's the second element. So in that case, this will be equal to. So we'll just say greater than or equal to. We might just be able to say equal to, but we can say greater than or equal to. In this case, we will need to append. We don't have enough storage, so we need to say self.data.append our new URL. Otherwise, we've already got storage space. We might have gone back in our list here. So we have the storage space already available, so we'll just add the URL to that location. And then finally, the last piece of this one is we need to change our max index. So we might be jumping to a new web page altogether. So we need to set our maximum index to this current location. This is like when you're browsing and you are going back and forward and then you just decide to type in some new URL. Now there is no future, there's no forward. Even if you've gone back a bunch and you had more forwards to go to, you're resetting the entire history with this as the top. All right, let's give a little bit more space here. Okay, now when we go back, we can go back any number of steps, but we can't go below 0. So in this case, we'll just say our self.current index is the maximum of the self.current index minus the number of steps, or 0. So we have to go back as many steps as we can, but we can't go below 0. So we'll take the maximum of the current index minus steps, or 0. So we never go below 0. And then we can just return the current index, or the URL at the current index. And we'll have to do something similar here for the forward. So not max, in this case we'll do minimum. So we can't go past our max index. So whichever one is smaller, the current index plus our steps, or the maximum index, because we don't want to go anything above maximum index. And then we just return the URL at that location. Okay, so I think that should be it. I think we're done. Let's try this out and see how it goes. Invalid syntax. Oh, I typed return wrong. Try that again. All right, that works. Let's submit this and see how we do. Not too bad. We pass and we beat 79% for runtime and 96% for memory. All right, I'll show you one quick and easy update we can make that should gain us a little bit of performance. So we have these max and mins. What if we did an actual just if statement here? So instead of making a function call, let's just do our own max and min. So let's see, let me grab this whole thing. All right, so if our current index minus the steps is greater than or equal to 0, we'll take that because this is the max that we're looking for. So let's see, we'll grab this. All right, so we're doing our own max calculation here. If the current index minus steps is greater than or equal to 0, then we'll set our current index to that. Otherwise, we'll set it to 0. And we'll do something similar down here with our min. All right, now we have our own sort of minimum calculation here, where if the current index plus the steps is less than or equal to our max index, we'll set our current index to that. Otherwise, we set it to the max index. Same functionality, Slightly different implementation, but it should give us a little bit of a boost in our runtime. Yeah, it does. So we go from 79% in our runtime to an 84%, a little bit of a boost. I'll show you one more thing we can do. So this is a standard if-else statement. We can convert this into something that's a little bit more compact and a little bit more Pythonic, as they say. So it'll be the same if-else, but instead of stacking it like this, we'll put it all in one line. So here it's the same thing. We're saying self-current index will be equal to the self-current index minus steps if the self-current index minus steps is greater than or equal to 0. Otherwise, we set it to 0. Same thing that we're doing here, just one line instead. So we can get rid of all of this and make this just a 2-line function. And we'll do the same down here. All right, so this one's a little bit uglier just because the names are a little bit longer, but it should still work. Let's see. Okay, it still works. Let's see if this gets us any performance gains. And it does, pretty significant. We're at 93% now with 10% for memory. But a 93% runtime is not too bad. All right, there are a couple things we could do to just boost this a little bit. We could change some of these names, make them a little bit easier to read. I don't know if it's worth doing, but let's see. All right, let's do it. So we'll just call this index. So any place we had current index, it's just going to be index. All right, I think I got them all. And we could, instead of saying greater than or equal to, we could just do greater than. Because if it's equal to, we're already going to set it to 0. So this might save us a little bit as well. Try it. Now that's what I'm talking about. We got a 97% for runtime, 37% for memory. So we do have a trade-off here. We drop in our memory, but, I mean, we do worse in our memory. But 97% for runtime, not too bad. I'll take it. All right, there's still a couple little things you can do to tweak this, but this is the basics. You've got your storage, you've got 2 indices to indicate your current and your max, and you just have to sort of shift them around based on whether you visit, you go back, or forward. Okay, that's all for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write a better browser history.